Today we are going to talk about some of the applications of mathematical concepts that we learn in engineering mathematics 3, including complex number and functions, vectors, and Fourier series and transform. So my applications will be in the concept of complex functions, but we have to bear in mind in my application, and so is Imran's. The calculations are a lot more advanced than what we learn in engineering mathematics 3. So in my application, I will talk about the guiding system of missiles and space shuttles.
So we'll start with missile launching, and here's a meager representation of the Earth. In fact, I'll say it's quite nice and pretty accurate. To make it easier for us to pinpoint a location, let's draw grids on it. On the map now is Petropavlovsk, which is in Russia, and New York. And here's the intended trajectory of the missile from Petropavlovsk to New York. To avoid interception, sophisticated encryption softwares use complex functions in exchange of standard coordinate system, but in this instance of an example, let's make it a lot simpler. These coordinates are de-encrypted from the complex functions and keyed in the launch controls in the submarine, from which the ICBM is going to be launched. And here's a simple depiction of an intercontinental ballistic missile or ICBM launching into space. And here's what it looks like from the ISS. Ooh, pretty. 26 million people dead. Well, that's all about it. Thank you.
Today I will explain on the application of the complex number in sports and exercise.
Complex numbers in signal processing. It is applied in sports device. As we are running, our heartbeat is detected by the chest belt. The transmitter on the chest belt will transmit the signal of the heart rate and display it on the watch monitor or smartphones. So, how the complex number is applied in signal processing? The answer is because complex numbers are an artificial device that makes computation and analysis easier. Note that sines and cosines are very important in signal processing. So, we need a way to do trigonometric manipulation with ease. This is one of Euler's formula that related in this application.
Assalamualaikum everyone. Now I'm going to explain about the vector application in range.
Cross product can be used in real-life application as simple as tightening the bolt by using wrench. If you are looking to the formula of torque, torque is the cross product of force and the distance between force and point of rotation. It means that the magnitude of torque that are being produced are depending on either the magnitude of the force, the distance, or the angle between force and the distance. This being said, as we understand from the trigonometric nature, if the theta is 90 degree, the magnitude of the torque will become maximum since sin 90 degree is equal to 1. As the angle is reduced where the wrench is pulled upwards, the torque also being reduced. Hence, it becomes harder to pull the wrench because the turning effect is lesser. It is more convenient if we can actually produce torque without us need to pull it with such large value of theta. This application of vector helps us to reduce some work and save our energy for something else if we can actually manipulate the surrounding based on the cross product formula.
Wish we could turn back time to the good old days when the mama sang us to sleep, but now we're
application of Fourier transform is
Noise is unwanted sound. Noise can be produced by many sources like mains vocal cord or an operating machine tool. So how can a song be made better without noise? Suppose that you are listening to a recording and there is a low pitch hum in the background. So we can use Fourier transform to filter out this. By applying a low frequency filter, we can eliminate the hum or noise.
Okay, hi everyone. Okay, I will explain about the Fourier transform or Fourier series application in engineering application. Okay, but basically I will tell about the Fourier transform first. The Fourier transform is basically the altering of the amplitude or the wavelength for the frequency from the reflected surface that we want to calculate. So the frequency will be altered into a signal that we use to interpret it by our
The
computer.
Fourier transform is not just limited to simple lab examples. Take for example the field of astronomy. Sometimes it is impossible to get all the information you need from a normal telescope and you need to use radio wave or radar instead of light. These radar signals are treated just like any other ordinary time-varying voltage signal and can be processed digitally. One recent example of this technique was the NASA Magellan satellite, which was released from the Space Shuttle Atlantis on 4th May 1989 and sent to Venus on a 15-month journey that took it 1.5 times around the Sun. Its mission was to map the planet with its sophisticated radar and to reveal surface features as small as 250 meters across as the clouds are too thick to penetrate. Magellan was also carrying another smaller antenna that pointed straight down and measured the time taken for a signal to reflect off the surface. Once identified, the pulses are stacked to produce a time series of echoes at each individual range. The Fourier transform of the series yields data about the Doppler shift of each point, providing the second dimension of the radar image. The data can be adjusted after collected by adjusting the length of the Fourier transform. This was used to build up a topographic map of the surface beneath the spacecraft. The black and white pictures that is sent back were strips of the planet's surface about 20 km wide from North Pole to South Pole. By the end of this mission, Magellan had far exceeded the mission objective by mapping 99% of the planet's surface. By combining this data with the earlier radar images, they were able to construct a 3D model of the surface of Venus. The model was animated to provide an impact movie that flies you across the Maxwell Mountains on Venus.